So a great free response question coming by way of TikTok from Nick's Numerals, sent to me by Hannah Webb. Uh, Taylor Swift's 1989, Taylor's version. That's important, right? That's important. It's become the most streamed album in a day on Spotify in 2023, most in one day. We just listened to Is It Over Now, and it's already up to 146.8 million streams. Yeah, which is not the most popular song on the album, incidentally. It's the second most popular. This Love is 193. Oh, Taylor's version came out? Oh, so it had a little bit of running. Okay, so it's catching it. Is It Over Now is really the slap song from that album. All right. Um, poor Harry. Poor Harry. Anyway, the total number of streams across all tracks can be modeled by the function S of t is 150 squared to t plus 400, where t is in days since it was released, and S of t is in thousands of streams, which we agreed we could probably adjust that to millions of streams right now. We'll work it in the respect of Nick's numerals. He put it at thousands of streams. And here's the new cover for 1989, which is great. She's showing her face now because she has the confidence to do so. Yeah. Determine the instantaneous rate of change at which 1989 Taylor's version is accumulating streams at t equals 4 days. Okay, so that's just the derivative, right? So if we do this without a calculator, we'll go as far as we can without a calculator, and then we'll show how to do it on the calculator. So first of all, what I would do is I would write S of t as 150 times t to the 1/2 power plus 400. Yes, yes? That puts it in a power rule form. So now S prime of t is going to be 1/2 times 150 times t to the negative 1/2 and then plus 0. So if I clean that up, half of 150, that's 75 all over the square root of t. 75 over the square root of t. That is the first derivative. Okay, so now we'll shift gears here. S prime of 4 is going to be 75 all over the square root of 4, which that's an exact answer, right? If we are taking a quiz or a free response, we would stop there, right? And what would the units be? Thousands of streams per what? Per day. Okay, it's a rate of change. Now we could probably fix that, right? We can clean it up a little bit. That's 75 divided by 2, and what's half of 75? 37.5 thousand streams per day. Streams per day. Now, we can actually do something here. We could take the 1,000 units. We could actually move that over 3 decimal places, right? So that would be 500 streams per day, which would be 37,500 streams per day. Now, in all fairness to Nick's numerals, he wrote a great question. But are these numbers realistic? Maybe for that one song, 37,000 streams a day. I think that's an underestimation. Yeah, but by maybe tenfold. Yeah, yeah. But anyway, my daughter listens to it that many times a day, so I know that's not the case. Okay, but anyway, if we were doing it on the calculator, here's how I would do it on the calculator. Let's say it's a calculator question on the AP exam. What would you need to show to get full credit? All you would need to show is S prime of 4. That indicates your method, and then I would go to Y1 and I would type it in there, 150 square root of x plus 400. And then from the home screen, remember, how do we do the derivative? Math number what? Math 8, the Fn derivative with respect to x. And then we go alpha trace number 1. And then we evaluate it at 4. And we get the answer of 37.5. Your calculator is doing it numerically, and it thinks it's actually not 37.5. But who's the boss? You or the calculator? We are the boss. But who is the man? Yeah, that would be Taylor. That would be Taylor. Okay. If she were the man, she would tell you to say it's 37.5 and not 0.5003. Okay. And then again, that would be thousands per day. All right, so a good question, right? Using the tangent line approximation, this is why it's germane to what we're doing, because we're going to be testing over this on your take-home test on Monday. Using the tangent line approximation of 4, estimate the total number of streams. Okay, so what do we need for the equation of a line? Point and the slope. Do we already have the slope at 4? It's 37.5. Do we have the point at 4? Do we have the y value at 4 yet, the streams? No, not yet. So let's find it. S of 4 is going to be 150 times the square root of 4 plus 400, which is going to be 700, I believe. And that's 700,000. But we'll just keep it in terms of 700. Okay, so we'll write the equation of the tangent line in whose form? Taylor's form. Ah, Brooke Taylor now. But really, we can, for this problem, we can call it Taylor Swift's form. Yeah, not Travis Kelce's form, but Taylor's form. Yeah. So I'll call it L. So L of x is equal to the y value of 700 plus the slope, which we found was 37.5, times x minus the x value, which is what? 4? Okay. Now, in the vicinity of the point of tangency, the tangent line is a good approximation of the function. So we can use it by either plugging in to find an approximation for s of t, or we can even set it equal to what we want s of t to be and find an approximate time for it. I should probably change x to t. I think I'm going to go ahead and do that. Since we're talking about time and days, we'll just change our independent variable to t. It wouldn't matter if it was in terms of x. All right, now, the notation is important. S of 5 is approximated by L of 5, which actually equals 700 plus 37.5, 37.5 times 5 minus 1, or 5 minus 4, which is 1. And so that ends up being 737.5 thousand streams. That's a lot of water. Okay. Now, the next one, is this an over or an under approximation? In real life, we would say everything's an under approximation, right? Because we never underestimate Taylor Swift. But according to the model, it's a radical function, isn't it? And what do we know about a radical function? Is it concave up or down? It's concave down over its domain. Now, if you didn't know the concavity, we could find the concavity by doing the second derivative. So let's revisit part A, and we'll bring down the first derivative when it was 75t to the negative 1/2 power. Let's say we don't know the concavity. We know the second derivative gives us that information. So I'll take the second derivative, and I get negative 37.5 t to the negative 3/2, which when I clean that up is negative 37.5 all over the square root of t cubed. What do I know about the sign of the second derivative in the vicinity between t equals 4 and t equals 5? For t equals 4 to 5, the denominator is always positive, isn't it? The cube root, the square root of something cubed between any number between 4 and 5 is always positive, and the numerator is always what? Negative. So what's a negative always divided by a positive? A negative. So here's what we would say. This is less than 0 for all t on the interval between 4 and 5. You can't just say it's concave down at 4. It has to be on the entire interval from 4 to 5. Now, if you forgot what the implication of that means is, the fact that it's negative, you draw your little Joe Biden figure, right? Negative, negative, right? And it's concave down. It's concave down. And then you can actually draw a little surfboard in his mouth, like that. And you can see now that anytime a graph is concave down, the tangent line is above the curve. So once we say it's less than 0 for all t from 4 to 5 days, I should probably put units there, I would say then so, here's a new column, so L of 5 over approximates, let me spell approximates here, over approximates S of 5. Got it?
So you wouldn't have to say the graph L of t of
No, you wouldn't have to mention concavity, and you wouldn't have to mention that the tangent line is above the curve. Those things are kind of taken for a given. You say the second derivative is negative everywhere, therefore it's an over approximation. Now, you could go on to say more. If the goal is communication, especially if you're trying to explain it to Harry Styles, right? Maybe you need to give him more information. Maybe you say since the second derivative is negative, the graph is concave down in the vicinity, which means, Harry, the tangent line is above the curve. which means it's an over approximation. You could say all that. There's nothing wrong with that, but the bare minimum would be second derivative is less than 0, therefore it's an over approximation. Hey, speaking of Harry Styles, my wife has this app called the Calm app, and she put it on the other night, and Harry Styles told me a bedtime story on Calm, on the Calm app, and I was asleep within like 3 minutes. It was surprisingly soothing. I was like, I was trying to thank Harry, but I was like, thank you, Harry. It was awesome. Um, all right, and then the last part here before lunch. Is there a time in the fourth month after release from 90 to 120 where she releases exactly what 1900,000, 1989,000? This is a what theorem? IVT. We need to figure out what S of 90 is, and we need to figure out what S of 120 is. So we can do that from the calculator. Alpha trace. Let's go to the home screen. We'll hit alpha trace number 1 of 90, which is 1823.024. We would report 3 decimals. And then alpha trace, oops, why does it keep doing that? Alpha trace number 1 of 120. And we get 2043.167. Okay, and then you would say, since her streams are continuous, right? By integer streams. We'll talk about by integer streams. I guess I don't know how Spotify does it. If you only listen to like part of the song, does it give you a partial stream? Let's just say it's continuous by integer streams. Okay, so we know since the inequality, since 1823 is less than 1989, which is less than 2043, comma, by the IVT, intermediate value theorem, and then we just reuse Nick's numerals words that we wrote here. There is a time in the fourth month after release from where it has exactly. So we just rewrite all this stuff again. I'm not going to rewrite all that because that's a lot to write. But we would write all of this right here. We would put it right here. Okay? So yes, there had to have been a time. That's a pretty clever problem. And it's actually legit math. The number's a little specious, but thank you Nick's numerals, and thank you Hannah Webb, and thank you China for a great app in TikTok. Oh, thank you Pennsylvania for giving us Taylor Swift. Yeah, thank you Taylor's mom and dad and her grandparents and Scott. Yeah, everyone who was involved. Thank you Jesus. All right, y'all have a good lunch.